Well, hello one and all, and welcome to our short on while loops. Now, life is full of surprises, and one surprise for me recently was taking care of this particular plant here. Now, it turns out this plant is pretty picky about the kind of water it gets and when it gets watered. I'm supposed to water this plant when the soil is dry, but not too dry, and so I have to kind of check every day what the moisture level is before I should actually know, should I water this plant or not. So I thought I could write a program to remind myself when to water this plant, depending on how dry the soil is. And one thing I've learned is that you can actually measure the moisture content of soil in percent water out of all the entire soil you might have. And soil is considered dry, supposedly, when it reaches a moisture level of 20% or a little bit less. So ideally here, I could write a program to maybe check for me once a day, let's just say, what the moisture content of this plant's soil is. And if it's 20 or less, go ahead and alert me that I should be watering this particular plant. So here I have a program called water.py, and this program actually uses a function called sample that I've written elsewhere, but I'm going to just import it and use it in this program. No need to worry about how that's implemented in this case. The purpose of sample is really to just well, hello one and all, and welcome to our short on dictionary methods. Now, a dictionary method is some function you can use to manipulate your dictionary in Python. You've seen some of these in our short on dictionaries, but I'll walk you through a few more here. So here we have a program called b.py, and my goal is that this replicates the functionality of the game Spelling Bee in the New York Times. If you're not familiar, what you're given is a set of letters. In this case, I have A, I, P, C, R, H, and G, and your task as a player is to come up with words that are made from these letters. So I have a few up here, each worth some number of points. So pear is one word that could be made using P, A, I, and R. We'll say that's worth 4 points because it is 4 letters long. Hair is one other word you could see, H-A-I-R. That's also 4 points because it is 4 letters long. And chair is one more, this one worth 5 points because we can do C-H-A-I-R, or 5 letters total. So here's how our game works. We'll show the user, welcome to Spelling Bee. We'll show them again the letters they can use, and we'll then go into this loop that will repeat as long as we still have keys in our dictionary. So to show you what's going to happen here, I'll run python of b.py, and I'll see, again, welcome to spelling B. I'll see what my letters are, and I'll see there are 3 words left. How do I know this? Well, I'm using the len function here, where len tells me how many keys there are in my dictionary. In this case, I have 3 keys, one called pear, one called hair, and one called chair. So I will guess a word. I'll say, well, I think I could make hair from these letters here. I'll hit enter, and I'll still see 3 words left. I'll type chair, and I'll still see 3 words left. So we still have this to do here. We need to check if this guess is in the dictionary, and if it is, we'll do something to add points to the user, or at least show them how many points they've received, as well as maybe remove this key from our dictionary so we don't let the user guess that word again. I'll exit this program here with Control-C, and now let's work on this to do here. So again, my goal is to check if the guess the user gives me is one of the keys of my dictionary. Well, if I want to get access to the keys in my dictionary, I can use a dictionary method. In fact, one of them is this, .keys, or this keys method gives me access to the keys in my dictionary. So in this case, again, my keys are pear, hair, and chair. And I could ask, is guess in the keys of my dictionary? And if it is, well, what should I do? I really want to show the user, in this case, the number of points they received. So I could go ahead and do this. I could say, maybe let's print here and say, good job. Good job. You scored some number of points. And points here. Let's actually replace this. Let's try using guess as a key to access the point value in our dictionary. I could do that like this, type the name of my dictionary, bracket, and then, in this case, the key, which is guess. So this will return to me the number of points that this particular word received. I'll run down below, I'll say python of b.py, and let's try this. I'll type in pear, hit enter, and we'll see, good job, you scored 4 points. But what I still see is this, there are 3 words left. So how could I maybe both get the number of points that this key is worth, this word is worth, but then remove that key from my dictionary? Well, it turns out there is a dictionary method to do just that. If I go ahead and run Control-C again, come back up here, I can make use of a method called pop. And I'll show you what this looks like. I'll say words, my dictionary name, dot pop. This is that method here. And I'll then supply as the argument here the key I want to pop from my dictionary. So what does it mean to pop? Well, pop here will return to me the value associated with this key and remove the key from the dictionary. It's going to say, okay, I've given you the value for pear. Let me now remove the pear key entirely. So let's try this. I'll say points gets the value, the return value of pop, which is, again, the value for the key that I've given. And I'll then be able to say that I actually scored some number of points, which I stored in this variable up here. Let's try this. I'll run python of b.py, hit enter, and now I'll type in pear, and I'll see, good job, you scored 4 points. And moreover, I'll also see there are only 2 words left. So it seems like, in this case, points. Pop did in fact remove the key that we then gave as input to pop. Let's try another one. I'll type in hair, and we'll see there are 1 words left. And then I'll go ahead and do chair, hit enter, and we'll see that's the game, because now there are no more keys in my dictionary. It is no longer true that the length of the words dictionary, in terms of its numbers of keys, is greater than 0. So 2 dictionary methods we've seen so far, pop and keys. What else could we do? Well, maybe one feature we could add is the ability to add this super word, if you will, which if the user guesses it, the game is over. So let's try adding this one. Let's try adding the word graphic. And graphic uses all 7 of these letters below, so it's worth 7 points. But because it uses all 7 letters, why don't we say, in this case, that the game is over. They've guessed this super word that uses all of the letters available to them. So how could we represent the game ending early if the user guesses graphic? Well, one way we could do this is just by clearing the dictionary in its entirety. If they guess graphic, let's not just remove the graphic key, but all the other keys as well. So let's try this. Maybe instead of if guess is in the entire keys of the dictionary, why don't we say if guess equals graphic in this case, if they do guess graphic, what do we want to do? Well, we might want to, again, clear the dictionary in its entirety, and thankfully there is another method called clear to do just that. If I type words.clear here, I'll remove not just graphic, but all of the points, or all of the keys in my dictionary. I might then say, you've won, for instance. So no points here, you've just won the entire game. I'll go ahead and save this program. And now, if we go down below and do Python of b.py, I'll then type in graphic, and we'll see you've won, and that's the game. So it seems like typing in graphic did, in fact, clear all the keys in our dictionary. So we've now seen one more, clear. If you're familiar with the game, though, you might also know that on the following day, because this is a daily game, they then tell you all the possible words and the number of points they might have scored for you. So if we have this dictionary of words here, let's say it's now the next day, how could we quickly iterate over each key and value in our dictionary and show the user all the possible words and their number of points? Well, in this case, we no longer really have a game here, so I'll really remove this loop here. And we're instead going to focus on, in this case, just iterating over, again, the keys and the values. Seems word, key, and value for you. So if we have this dictionary of words here, let's say it's now the next day, how could we quickly iterate over each key and value in our dictionary and show the user all the possible words and their number of points? Well, in this case, we no longer really have a game here, so I'll really remove this loop here. And we're instead going to focus on, in this case, just iterating over, again, the keys and the values inside of our dictionary. And there is, again, a dictionary method to do just that. This one is called items. So if I type the name of my dictionary, words, .items, this gives me back a set where it actually gives me both the key and the value associated with my dictionary. So for instance, if I do a loop here for word, comma, points in words.items, I'll fill this in later, what I'm really getting back from words.items is a way to iterate over, in this case, the keys. This is the first value here, and the values, the points. I could also write this like this, key, comma, value. This is really what we're doing just generally, iterating over the keys and the values. But in this case, I have words as keys and points as values. So I'll say this, word, comma, points. And I could then use these values inside of my loop. I could say something like this. Let's print an f string and say, word, this key that I have, was worth some number of points, just like this. And now if I run this program, Python of b.py, I'll then see all the keys and all the values, now in this case in my terminal, thanks to items. So you've seen here a few more dictionary methods. Excited to see what you'll build next with dictionaries. See you next time. Well, hello one and all, and welcome to our short on for loops. If you're familiar with the Mario video game series, you might be familiar with Princess Peach and her castle, Peach's Castle. And we'll imagine together that Princess Peach is inviting some guests to join her at a ball at Peach's Castle at 7 p.m. this evening. Now, thankfully, Peach has automated the process of writing letters to her guests. In fact, we have here a function called writeLetter, which takes in two arguments, one called receiver and one called sender. And notice how the purpose of writeLetter is to return to us a fully written and formatted letter to a receiver from the sender. In particular, we're using Python f-strings here to interpolate the values of receiver and sender. For instance, if our receiver were to be Mario, as it is on line 2 here, and our sender were to be Princess Peach, well, we should see at the end of this a letter that says, "Dear Mario," and then some text down below, "Sincerely, Princess Peach." And then we'll take that letter and print it out to our terminal to make sure everything is all correct. So let's see what happens if we run this program. I'll go ahead and open up my terminal here, and I'll run python of letters.py. I'll give us a bit more space so we can see all the letters fly by here. If I hit enter, well, we'll see some letters being printed out to each of our guests here. We see we invited Mario first. That seems good. Invited Luigi next, Daisy as well, and finally Yoshi. So this program seems to work, but there's a question of how well it's designed. If I were to show you again what this program looks like, let's think of some scenarios where this might get a little tedious. Let's say we're only inviting 4 guests now, but we also want to invite other folks too, in which case our guest list get pretty long. And to do that, I need to kind of copy and paste to add new letters to new characters as well. Now, if you find yourself in this kind of situation where you're repeating something for each maybe guest you have, you might think to use something like a for loop. A for loop, in fact, is great when you know how many times you want to iterate, or you want to do something, like write a letter for each person or each thing you have in some list, like a guest list in this case. So let's actually make ourselves a guest list and write a for loop to write a letter for each person on that guest list. Well, in main here, why don't I go ahead and update this program to instead keep track of a list that we're going to call names. And this names list will be our guest list for the ball. I'll go ahead and maybe add a few names to the guest list. I'll go ahead and add Mario here. and Luigi as well. Daisy to Daisy and Yoshi, just like this. And now I have a guest list of names I'm hoping to invite. Well, now what should we do? We know we want to write a letter for each person that is going to be in this list. So I think I can actually get rid of this code down below here and instead think about how I could use a for loop. Well, one way to use a for loop, as we saw in lecture, is to use numbers and iterate over every number in some range of numbers. So I could write some code like this: for I, which is usually the name we give to some variable that is iterating, changing on each iteration, for I in, and then the Python range function. And range will give us a list of numbers from 0 up to, but not including, the value we pass in as input to range. So in effect, maybe I want I here to iterate, let's say, from 0, maybe the 0th index of this list, to 1, the first index of this list, to 2, the second index of this list, and then to 3, the third index of this list. Again, indexing from 0 with Mario here. So to do that, I can actually pass into range here the length of our list. Here I'm saying len of names, which in this case is 4, but range will give us 0, 1, 2, and 3. Let's try this out, though. I'll go ahead and print I down below, and ideally I'll see 0, 1, 2, and 3, each of the indices in this list here. I'll go ahead and run python of letters.py, and we'll in fact see 0, 1, 2, and 3. That seems to work just as well. But of course, we don't want to invite these numbers to our party. We want to invite Mario, Luigi, Daisy, and Yoshi. So one way to approach this is to use I to index into our list. I could do something like this. I could say names, bracket, I. And on each iteration, again, I will change. First it will be 0, then 1, then 2, then 3, giving us different names in our list here. I'm going to go ahead and run letters.py again, and we'll see now the names we're hoping to invite. And this is promising because I think I could actually use these as input to the write letter function. Let's try this. If I were to go ahead and print not just names bracket I, but the result of write letter given names bracket I as the receiver and Princess Peach as the sender, I think we'd start to get the same letters we saw last time. Notice a few things first here, though. Again, I will update on each iteration of our loop, that is from one traversal or time going from top to bottom in this indented code here. But what will change, or will actually stay the same, is Princess Peach here, the name that will be the sender. That will not change on each iteration because it doesn't depend on anything in our loop itself. So let's go ahead and run this. I'll run python of letters.py, and we'll see the same letters down below here as well. So same result, but what have we given ourselves here? I'm now able to make this program much more flexible, much more adaptable if I were to invite additional guests. We could very quickly, let's say, add a guest like Bowser. Everyone is invited here. And we could print out a letter for Bowser just like that. No copying and pasting, just adding Bowser's name to our guest list. Now let's uninvite Bowser, actually, and think through some ways to improve the design of even this little segment of code here. Now this works. It's actually pretty well designed, but I think we could make it a little more readable, maybe stylistically better too. And we could do that using a feature of Python, which is we can actually iterate over any kind of list directly. This is a list here. Names is a list of, in this case, names. So we can actually use it as the second part of our for loop. Say for I in names. And in this case, I will actually temporarily refer to each of the items in our list, or the names in our names list. I will first be Mario, then Luigi, then Daisy, then Yoshi, updating on each iteration. But I don't need to use I. In fact, I can give it any name I like as long as I am consistent with that name. I could say something more English-like, like for name in names, because we have a list of names plural, but each item is a single name, singular. So now, on the inside of my for loop, well, there's no longer an I variable to use to index into names, but I've conveniently given myself now this variable called name that I can just use. Again, first name will be Mario, then Luigi, then Daisy, then Yoshi, updating on each iteration as we loop through our for loop. And once we get to the end, once there are no more names, we'll simply stop looping and exit our program. Let's try it here. I'll go ahead and run python of letters.py, and we'll see the same results, but now with a bit better English syntax and probably better stylistically as we're writing programs like these. So for loops, again, are powerful when you know how many times you want to loop, or when you want to do something for each item you have in some list, or more generally, some iterable, something can be iterated over. This was our short on for loops. We'll see you next time. Well, hello one and all, and welcome to our short on lists. Now we'll be exploring how we can store information in certain orders within Python. And I have here a game called Super Mario Kart, which, if you're not familiar, is a racing game for the Nintendo Entertainment System way back in the, I don't know, the 90s or so. And the idea is you would play as Mario, Luigi, Princess Peach, and race to get a certain place in the race, whether it was first, second, third, first, or fourth, whatever it was. We're going to make a list here to represent the racers and their place when they cross the finish line here. So I'll come to my terminal here, and I'll go ahead and code results.py. And to make a list in Python, well, I can think about how I want to store these racers. Maybe Mario came first, followed by Luigi. So Mario in first place, Luigi in second place. I could make a list in Python by first giving it some kind of name. So here, I'll give this list the name results, just like this, results. And I'll say results equals, in this case, well, a list. And a list in Python is denoted by these brackets here, these square brackets, opening and closing. Now within these two brackets, I can actually place this information in the order I want it to be. So first, I could place Mario, saying Mario came first in this particular race, followed by, in this case, Luigi, just like this. And notice how each of these elements is separated by a comma. So Mario came first, followed by Luigi. So here, I've created a list just explicitly on my own. I made a list, add the elements, and so on. But often in Python, you might have a list you want to dynamically add to as your program runs. here I've initialized a list, but how could I keep adding more racers in this case? Well, let's say after Mario and Luigi comes Princess Peach. So I could, if I wanted to add on to this list, use a method called append. Append adds a new element to the end of this list here. So I could try results.append. I take my name of my list, use dot, and then append to add on some new element at the end of this list. And back in the Super Nintendo Entertainment System era, Princess Peach was actually just called Princess, so I'll use that name here. And I'll add the princess to our list here, saying that she came in third. Now let's see where we're going here. So if I were to print the results, I can use print here and just call print results. I can then run Python of results.py, and down below, I'll see Mario, Luigi, and Princess. So Mario in first place, Luigi in second place, and Princess in third place so far. Well, maybe as the race goes on, we have more racers who finish, so I could keep appending if I wanted to. I could say results.append, and maybe after Princess comes, let's say, Yoshi, another player you can play in this game. After Yoshi comes Koopa Troopa, and then after Koopa Troopa comes, let's say, Toad. So these are our results. I'll go ahead and run python results.py. And now we'll see our results for the first 6 finishers. Again, Mario in first place, Luigi in second, Princess in third, and the rest following thereafter. Now, we could, if we wanted to, try to add more than one racer at a time. Maybe we get the results for Bowser and Donkey Kong Jr. at a pretty similar time, so we could try to add both of them at once to our list. One way to do this would be as follows. I could go ahead and say results.append and add on maybe a list to my list. I could try adding on, in this case, Bowser, followed by Donkey Kong Jr. And hopefully what we'll see is that these two elements, these two racers, Bowser and Donkey Kong, get added at the end of our list all at once. But let's see. If I were to run python of results.py, well, we'll see here that we still have our first 6 or so finishers. But then at the end, I'm noticing that Bowser and Donkey Kong Jr., well, they're added into our list, but they seem to be inside of a list themselves. Notice the curly brackets around their names there. So how could we fix this? Well, if we want to add onto our list using a list itself, we can't use append. Append actually goes ahead and adds the list itself to our list. So why don't I go ahead and remove this? I'll say results.remove, which is another method I can use to remove items. And I can give as input to remove the list itself. And why don't we do this instead? I'll say results.extend. Results.extend, and I can give extend now a list, but it will really take each element of that list and append it to, in this case, my original list called results. So to be clear, we're starting now with a list of 2 racers who finished, Mario and Luigi. We're adding in Princess, Yoshi, Koopa Troopa, and Toad, each individually. We tried to add the list of Bowser and Donkey Kong Jr., but we realized we can't use append for that, so we removed them instead. And now we'll try extending our list, which will take each of Bowser and Donkey Kong Jr. and add them individually to our results list here. So let's try this. I'll run python of results.py, and hopefully I'll see down below that we can in fact see all 8 now of our finishers, each on our list, with no sublists, if you will, inside of our one larger list. So here is an example of our list. Now we've added racers to it. What more can we do with lists? Well, let's go ahead and try to maybe take our list as it exists down here. I can really just copy and paste this. Actually, let me not copy paste. I'll come back up here and I will do results equals, and I'll type in Mario, Luigi, Princess, Yoshi, Koopa Troopa, Toad, Bowser, and Donkey Kong Jr. So a bit of a long list we have up here, but this will enable us to see a few more features of lists as well. So one other one we want to be familiar with is just getting a sense of what remove might actually do here. So here I have a list where Bowser is clearly part of this list. Bowser, it looks like, is in 7th place in this race, but I could remove remove Bowser entirely. I could say results.remove and then give as input Bowser. And this remove method will actually search through my list and find the first instance of Bowser and remove that element as well. So I'll run python of results.py, and we'll see down below that Bowser is no longer in our race. But let's say Bowser tries to cheat the system a little bit, and we remove Bowser, but we later go on and try to add Bowser back in. Well, we saw with results.append, if I were to append Bowser, Bowser would show up at the end of our list, in this case in 8th place. But we don't really want that for Bowser. Bowser would, of course, prefer to be in 1st place. So I could try this. I could try a new method, one called insert. And insert takes as its first argument the index at which I want to insert some given element. So recall how our lists are actually indexed from 0. 0 is the first element. 1 is the second element, and so on and so forth. So for instance, Mario here is at the 0th index, Luigi at the first index, Princess at the second index. So if I wanted Bowser to kind of sneakily move up to 1st place, I could try to insert Bowser, of course, at the 0th index, and say as the second argument, the actual element I want to introduce, so Bowser in this case. So what have we done? We've had our list of results up here with Bowser in 7th. We've removed Bowser, but then later on we go back and insert Bowser in 1st, or at the 0th index as well. Let's try printing our results down below, and we'll see that Bowser appears now to be in 1st place at the 0th index of our list. Now, one more thing we can do with lists, one more method to consider here, is one called reverse. In fact, I can call results.reverse if I wanted to flip the standings a little bit, turn whoever is in 8th into 1st, whoever's in 1st into 8th, and I could actually run this now and see the result. And we'll see our list has been reversed. We have Donkey Kong Jr. now in 1st, who was previously in last place, and Bowser, who was previously in 1st place, is now here in 1st. So these are a few methods to be familiar with as you go off and do work with lists. We've seen here append, we've seen extend, we've seen remove, and we've seen insert, and of course at the end here we've seen reverse. That's it for this short on lists. We'll see you next time. Well, hello one and all, and welcome to our short on list and dictionary comprehensions. In Python, this idea of a comprehension is a quick way to build up a list or a dictionary from data you already have. Now, if you've been to Boston, you might have been to the John F. Kennedy Presidential Museum and Library. This is, in fact, a museum and library dedicated to John F. Kennedy, a famous politician from the Boston area. So I have here a program called comprehensions.py that looks at one of the addresses, the speeches that Kennedy gave when he took office as President of the United States. Here is a file called address.txt, which actually includes the full text of Kennedy's inauguration address that, again, he gave when he became the President of the United States. In comprehensions.py, my goal is to analyze this address, looking for what words.py he gave when he became the President. Of the United States. In comprehensions.py, my goal is to analyze this address, looking for what words Kennedy used as he took that office. So let me walk you through the program here. I have here a dictionary called count, initially empty, but as I go, I'll build up this dictionary down below. I also get this list of words using this function that I made called getWords. You don't need to know how it works, just know that it simply opens up this file, address.txt, and returns to me a list of individual words found in this text file here. So for instance, one of the words in the list might be we, another word might be observe, today and not, I simply get back this file as a list of the words inside of it. Now, in comprehensions.py, with that list, what do? I simply iterate over each word in this list, and I'll ask a question. If I've already added this word to my counts dictionary, I'll increase its count by 1. If that word is not in my dictionary, though, I'll set its count to 1. And this way, at the end of this loop, I have, in my dictionary, 1 key for every word in address.txt, and a value which corresponds to how many times that word shows up in Kennedy's address. I'll then save this dictionary in the form of CSV using this save counts function that, again, I wrote myself. So why don't I go ahead and run comprehensions.py, and let's see what we get. I'll open up, in this case, counts.csv, and this is the output of this program. So you'll see here words on the left and counts on the right, and in this case it seems like the word the appears 83 times, the word of, in this case, .csv, and what we get. I'll open up, in this case, comprehensions.py, and let's see what we get. I'll open up, in this case, counts.csv, and this is the output of this program. So you'll see here words on the left and counts on the right, and in this case it seems like the word the appears 83 times, the word of appears 66 times, and appears 37 times. So seems like we're off to a good start. This seems to be working, but there is in fact a bug. And what is that bug? Well, if I look at this word the here, notice how it's all in lowercase, T-H-E. If I try to find the word the elsewhere in this file, I bet I probably could. Here's the at the very top. That's them, that's not the. The. So here is the with a capital T and T-H-E. So it seems like when we iterate over our words here, some of them are lowercase, some of them are title cased, and those two words are seen as different. We're not comparing words case insensitively. So one quick fix here is actually to convert all the words in this list to lowercase. So let's try that. In comprehensions.py, I now have this list of words that I got directly from address.txt. It maintains that capitalization. But what I really want is a list of lowercase words that I could then iterate over just like this. Now, the question then becomes, how do I make this list of lowercase words? Well, if you're familiar, I could use a loop. I could iterate over every word in my list of words, changing them to lowercase, appending them to some new list. I could do that, or I could use a list comprehension. These are great ways to build up a new list from some list you already have. So here I have this list of words, but I want to transform it. I want to take every word in this list and convert it to lowercase, giving myself back a new list at the end. So to make a list comprehension, there are a few pieces of syntax. One is that list syntax here, these brackets which indicate I'm making some new list. But inside of this syntax here, you don't type your own individual words. Like I wouldn't type the or whatever comes next, country, for instance. I instead use a certain kind of for loop. I'm going to iterate over every element in my previous list and do some transformation to it. So let's see the simplest list comprehension I could make here. I could say word for word in words, a bit like English. What I'm saying here is I want a list, and this list will be composed of the word element for each word that I have in words. Or another way of putting this is I'm really getting back the exact same list. I'm asking for every word that exists in my words list, every element in this list, give me back that element unchanged as a new list. Now, this isn't really interesting, it isn't really helping me here, but what would help me is this. I could transform this word in any way I want to. I could make it lowercase, for instance, by typing word.lower. In this case, what I'm now asking for is the lowercase version of each word in the words list as a new list. And this is my list comprehension. I'm still iterating over every word in the words list, but I'm now transforming what I get back into lowercase and giving the entire thing back to me as a new list. No need for a separate loop here. I'm doing this all on one line. So let's see if it works. If I run python of comprehensions.py, I'll then go back to count.csv, and if I scroll up, well, it seems like we've consolidated our values for the. We no longer have title case the or lowercase the. We just have only lowercase the and an appropriate count in this case. So again, comprehensions, great for transforming your lists for some other use case. And this is what I've done to help us lowercase all those words there. Now, list comprehensions, you can also use them to filter your lists if you'd like. So let's say I don't just want every word in this list of words, now converted to lowercase. Maybe we no longer have word in this list of words, now converted to lowercase. Maybe I only want those that are longer than 4 letters, for instance, getting to the more interesting words Kennedy spoke about when he gave his inauguration address. I could append here an if statement. If, let's say, the length of this word is greater than 4, we'll only include it in this list if this condition is true. So let's read this, again, a bit like English. What I'm asking for here again is every word in this list of words, but I want to tweak every word just a little bit. I want to make every word lowercase, and I only want to include it if the length of that word is greater than 4. Let's try this. I'll run python of comprehensions.py. I'll go back to counts.csv, and now I see here only those words that are greater than 4 letters long. And so we here's pi. I'll go back to counts.csv, and now I see here only those words that are greater than 4 letters long. And so we see here the word world appearing 8 times, which makes sense because as Kennedy gave his address, he was talking about the US's place in the world. Well, let's see. We've made here a list comprehension, but we also promised to talk about dictionary comprehensions. So if I look at this, loop down below, I can actually simplify this using a dictionary comprehension, because a dictionary comprehension is doing much the same thing. It's going to iterate over every element in some list and build up for me a dictionary based on those elements. So let's try making our own dictionary comprehension. Instead of setting counts up above, what if I did this? I could say, let's make the dictionary counts here, but let's do it in a way that is a little more Pythonic. Well, I can use this same loop syntax for blank in blank. I could say for word in words. I'm building up this dictionary by looking at every word in the words list. And now what do I want to do with every word in the words list? Well, I want this word to become a key in my dictionary, and I want the corresponding value to be the number of times that word appears in the words list. So this here is my dictionary comprehension, if I actually use lowercase here for lowercase words. And let's read it now a little bit more like English. I'm again iterating over every word that I have in my lowercase words list. But now I'm building up a dictionary as I go. I'm saying for every word in this list of lowercase words, let's do the following. Give me a key called word and set the value to the count. That this word appears in the lowercase words list, just like this. So here, I've replaced that entire loop with my now dictionary comprehension, a way of building up this dictionary by using some more Pythonic syntax. I'll now run Python of counts up above. What if I did this? I could say, let's make the dictionary counts here, but let's do it in a way that is a little more Pythonic. Well, I can use this same loop syntax for blank in blank. I could say for word in words. I'm building up this dictionary by looking at every word in the words list. And now what do I want to do with every word in the words list? Well, I want this word to become a key in my dictionary, and I want the corresponding value to be the number of times every word as I value to this words list. With my now dictionary comprehension, a way of building up this dictionary by using some more Pythonic syntax. I'll now run Python of comprehensions.py, and I'll look at counts.csv, and we'll see the same results. Really, I've just simplified what I had before. So this then can be my entire program. I've taken a program that was upwards of 15, 20 lines and shortened it down in this case to just 4 or so in the main function. This is the power of list and dictionary comprehensions. Hope you enjoyed this short. We'll see you next time. Well, hello one and all. And welcome to our short on list methods. A list method is some function you can use to manipulate the data inside of your lists. Now we'll be looking at list methods by also looking at this game called Sokoban. If you haven't heard of it, it's a classic game in which you play as a warehouse worker to move various boxes to the right locations. So for instance, here's a person playing the game where they'll move these boxes to each of the red dots here. Turns out this game is actually pretty hard to train an algorithm to play. It requires a lot of human intelligence. But really the solution to this game is just a matter of moving up, down, left, or right. And it's really a sequence of those actions we're going to try to store as a solution to this game. So what better way to store these actions than in a list? Now, let's go ahead and go to this program here called sokoban.py. And the goal of this program is to take as input an action the user might take in the game, in this case, moving up, down, left, or right, and storing that action inside a history of actions. So for instance, I can go down my terminal here, and I can run python of sokoban.py, and I'll say, let's first move up, just like this, and now I have up in my list. I could say, let's move down, and we'll say down in our list. I could move right and left. I'm just adding things to my list, the history of actions I've taken as I play this game of moving boxes to the right locations. So we seem here to have a way of keeping track of our history in this game, but what else could we do? Well, in the game, you can actually undo some action. If you move a box somewhere or move your player where you don't want them to be, you can undo that action by typing something like undo, for instance, or a certain command sequence in the game. So if we wanted to replicate that action, what could we do? I can type undo here as my action, but I then just see undo added to my list. That's not exactly what I want. So let's go back to our program here and see what we could do. Well, I have the user's action here, and maybe I could ask a question. If action is equal to undo, I want to do something else. I don't want to append the action to my history list, as we've seen in another short on list, this append method here. What I instead want to do is something called popping the last item off of my list. So let's make sure that we only append if we haven't typed undo. We'll make these two mutually exclusive. But now when I type undo, I don't want to add this action again. I want to actually just remove the last one. And turns out there actually is a method for this called pop. So if I type this, history, name of my list, dot pop, this will remove the last item from my list. I could actually get it back as the return value of pop. I could say undone here. This is the action I have undone. And then I could do something like this. I could say print. Let's print, in this case, what we have undone. In this case, we have undone this very last action. And now if I print, actually no, if I don't print, if I run my program, python of sokoban.py, I'll type up, down, left, and right. And now if I type undo, well, I see undone, right. I took off this last element of my list. I can keep doing that. If I do undo again, I've now taken off left, undo again, I'm back now at my empty list. So pop is a list method that allows you to take off the last element of your list. What else can we do here? Well, if a user wants to restart the game, we could also let them do that. We could clear our list entirely. Let's say we have another action they could take. This one might be called something like restart. And if the user wants to restart the game, we could use the clear method here. In this case, history.clear. This will not just remove the last element of our list, but really remove the entirety of our elements. It'll take out all the elements of our list. No need to get a return value here. Our goal is to clear the list in place. I'll go ahead and run python of sokoban.py, and I'll type in up, down, left, and right. And now, if I type in restart, we'll go back to our list as it was at the very beginning. So these are a few more list methods beyond those you've seen in the list short. We're able here to clear our list, remove all its elements, or pop certain items, remove the last one from our list. These are super helpful when you're building up lists and trying to manipulate data inside of them. This then was our short on a few more list methods. We'll see you next time. Well, hello one and all, and welcome to our short on string slicing. I have here a program called phone.py that stores for me a phone number as a string. This is common for phone numbers because phone numbers might often have other characters inside of them beyond numbers, things like dashes or country codes, for instance. So we'll use a string to store this phone number. But there are certain interesting parts of a phone number that I might want to use in my program. So here, as you might know, in the US and other places too, the first 3 digits of a phone number are known as the area code. They can tell you where a caller is calling from. Now, the last 4 digits might be useful too. They could be used for security. Let's say you're trying to verify someone's identity. You could ask them, in this case, for the last 4 digits of their phone number. So there are reasons here to try to get access to certain parts of this phone number inside of this larger string. Now, thanks to Python and thanks to string slicing, we can actually get back certain substrings from our larger strings. Let's see how we can do that. Right now here, I'm printing just the phone number. I'll type python of phone.py, and I'll see in this case the entire phone number just as it is. That makes sense. But let's say I want to find, in this case, just the first 3 digits. I could do this. I could say phone, bracket, and then inside of this bracket, I could tell Python which indices I want to get back from this larger string. Here, let's check here. This is the first index, 0, then 1, then 2. So I really want the first 0, 1, and 2 indices from this larger string and make that my substring that I'll print out to the terminal. So to get access to those values here, I can use this syntax. I could say, I want to start at the 0th index, and I want to go until I hit the 3rd index, exclusive. And so this is a feature of Python string slicing. The first number you include will be inclusive. I will include the character at this index. The second number you include will be exclusive. I'll go up to, but not including, the character at this index. So if I now run python of phone.py, well, I'll now see 617, the first 3 digits of this phone number. I could even simplify this a little bit more. Instead of specifying that I want the 0th index here, I could actually just leave this blank. If I leave it blank, Python will assume I want to start at the beginning of this string and go up to, but not including, whatever character is at this index here. So I'll say python of phone.py, and I'll again get back 617. But now what if we want the last 4 digits? How could we get those? Well, if I do this, let's count up here, 0, 1, 2, 3, 4, 5, 6, 7, 8. In this case, I want the character or digit at the 8th index all the way up to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So really up to 12 exclusive, so 8, 9, 10, 11, those last 4 digits. If I run python of phone.py, I will see those last 4 digits. But this could be really tedious. I mean, you don't really want to be looking at your strings, counting individual characters. So there are other ways to do this. One simplification here might be similar to what we just did. I could remove a value for this second number here, and Python will assume I want to go from the character at the 8th index all the way to the end of my string. So I could say python of phone.py, and that will give me back the full 4 digits here, similar to using, in this case, 12. But I'd argue this is still not the best design because what if my phone number changes? I could type +1 here, and I could do Python of phone.py, and now my program is broken because I added 2 more characters, really 3 at the beginning. So thankfully, there is a way to solve for this problem. If the characters you want are always at the end of your string, you can get them using a special kind of indexing that Python gives you access to. I'm going to type here -4, which seems a little bit strange, but let's visualize it. So again, in our string, this is index 0. But instead of going forward here, let's actually work backwards. Again, 0 with index. If I go back around to the end of my string, this, according to Python, is index -1. And this is index -2, index -3, and index -4. So it seems like I've gone back around on my string 4 characters, and I'm now asking for everything until the end of my string, thanks to this colon with no particular number at the end of it. Let's try this. I'll run Python of phone.py, and now I'll see those same 4 digits, 1000. So thanks to string slicing, we can take these longer strings and make substrings. You've seen how to do that in a variety of ways. This then was our short on string slicing, and we'll see you next time. Well, hello one and all, and welcome to our short on tuples. Now, do you know where exactly in the world you are? You might know your neighborhood, your state, your country, or so on, but it turns out there's another way of identifying where in the world you are, using, in this case, lines of latitude and longitude, or your coordinates. So I have here a picture of the globe with lines of latitude and longitude laid on it. Latitude tells me how far north or south I am, whereas longitude tells me how far east or west I am. And it turns out you can combine those 2 values, a value for latitude and a value for longitude, to get your exact coordinates, a certain place on the globe where you are. For instance, here on campus, Sanders Theater has these coordinates in terms of the decimal degrees system: 42.376 for latitude and -71.115 for longitude. So let's see how we could represent this idea in code of taking 2 distinct values, one for latitude, one for longitude, and combining them into one single value, our coordinates as a whole. So here I have a program called location.py, and again, my goal is to represent where in the world world we currently are. Well, I have here my main function, and I could type into it a value or a variable called coordinates. But I need to assign this variable some value. Well, I could maybe make two separate ones, one like latitude and give it the value 42.376, or one like longitude and give it the value -71.115. But what I want is the combination of these two values, where I first see the latitude value and I next see the longitude value for my entire coordinates. So this is where a tuple comes really handy. I could go ahead and make again, a variable called coordinates, and I could assign it now this tuple, which will actually combine for me these two values, latitude and longitude. To make a tuple, I can use the opening parenthesis and the close parenthesis. And inside, I can simply list out these values, much like I would in a list, by separating them by commas. So here is that value for latitude, and here is that value for longitude. I've now taken these two distinct values and packaged them together into a single variable in the form of a tuple. Now, here I'm using a tuple to store my coordinates all as one value, but let's say I wanted to maybe break them apart again. Well, I could certainly do that in a way you might be familiar with if you've used lists before. Why don't I try now printing the values of latitude and longitude separately? So here, I'll go ahead and print latitude as an F string, and I'll provide here some value for latitude. Well, I can take my coordinates tuple, and I could find that very first value in it by using index 0. I'm indexing into my tuple, much like I would a regular list, to get access to this first value here. I'm now going to do the same thing for longitude and get back now this second value using index 1 for longitude. I'll go ahead and print python of location.py, and I'll see both latitude and longitude down below now split apart from this single coordinates tuple. Well, tuples have this nice feature of being able to be unpacked as well. So if I have these two distinct values, I could unpack them into distinct variables at any time. And by unpack, I mean take these individual components and make them their own distinct variables. So here I could type something like latitude and longitude, two new variables, and set them equal to coordinates. And the way to read this is I'll take the coordinates tuple and unpack its values into two distinct variables, latitude and longitude. The first value in coordinates will go to latitude. The second value in coordinates will go to longitude. Now I could do this. I could simply say latitude here, and I could simply say longitude here. I'll run Python of location.py, and I'll see the exact same results. So as you've seen here, these tuples behave an awfully lot like lists, but they aren't lists. So there's a big question. Why would I use tuples and not use lists? Well, tuples, it turns out, have a pretty big trade-off. I actually can't add or change any values inside of a tuple. Let's demonstrate this. I'll go over here to line 3, and I'll type coordinates bracket 0 to index into this first element of the tuple, and I'll then let's demonstrate this. I'll go over here to line 3, and I'll type coordinates bracket 0 to index into this first element of the tuple, and I'll then set it to some new value, maybe putting this person on the other side of the world, and let's see what happens. I'll run Python of location.py, and I'll get an error. I'll see that the tuple object does not support item assignment, nor does it support adding values after I've created it. So why would I use a tuple and not a list? Well, if I'm very sure that I'm not going to change these values or add values, I actually do get a benefit. I get a more efficient way to represent this collection of data. Let's try this. I'll go ahead and make a coordinate tuple, and I'll make a coordinate list using, in this case, my list syntax. And let's take a look at how much space each of these data structures, each of these variables takes up in memory. Well, here, to do so, I'll import a module called sys, and I'll use a function inside the sys module called getSizeOf. This will tell me the size in bytes for any Python object or variable that I have, at least in this program here. I'll run print, and I'll make an f string. And I'll say that I want to use the sys module, run this function getSizeOf, and I'll pass as input the coordinate tuple here. And I'll say this is some number of bytes. I'll do the same thing here for our coordinate list. And now, if we run this program, let's see how they differ. I see my coordinate tuple takes up 56 bytes, whereas my coordinate list takes up 72 bytes. They have the exact same data inside of them, both latitude and longitude, but one is a more efficient way of representing it in terms of memory. So why use a tuple? Well, again, if you're very sure you won't be changing values or adding to them, but you are sure you want to be efficient with memory, this is a great way to represent your data. This difference of 20 or so bytes could really pay off over millions and millions of rows in your data, or millions and millions of people who are sharing their coordinates. This then is our short on tuples, and we'll see you next time.